It's team time. It's team time. It's team time. Hey, hey, hey. It's team time. It's team time. It's team time. Hey, hey, hey. STEAM scholars, we're going places. Let's get ready for liftoff. To begin, we will start by going over the design process, followed by saying what STEAM stands for. The design process is something we as engineers and scientists will use every time we create or do an experiment. Feel free to say each step with me. With any project, we are going to A. Ask, what is the problem or what am I trying to create or solve? B. Brainstorm. How can I solve or make what I am trying to create? C. Collect. Collect information, data, or use prior knowledge to help you create your project. D. Develop. Start creating your project. E. Evaluate. What works, what doesn't work, and what can you do to make it better? And F. Fine tune. I will try again until my design is where I want it to be. STEAM stands for science, technology, engineering, art, and math. Great job! It is student question box time where we want to hear from you. Last time, our questions read, how do heavy objects like a plane stay in the air? What would happen if we didn't have planes or helicopters? And what are planes and helicopters used for? Keep these questions in mind as we explore throughout this unit. Let's explore. Last time we met, we went over aircraft, specifically airplanes. Aircraft are machines that can fly because of the force of air upon its wings. Force is the push or pull upon an object. We also learned about aerodynamics, which is the study of how air moves around a solid object. Let's go over the 4 forces of aerodynamics. The first one is thrust. Thrust is the force that pushes something forward, like the flapping of a bird's wings or a propeller on a helicopter. Next is lift. This is the push or force that needs to be applied to move something up or rise. This is the opposite of weight. Weight is force caused by gravity, which pulls an object down. The weight of the object tells you how strong the push needs to be. And lastly, drag. Drag is the force that slows down a flying object. The invisible gases in the air causes the object to travel slower than it would in space without air. Today, we're going to focus on helicopters. A helicopter is a type of aircraft that lifts off and lands vertically. Helicopters can lift off almost anywhere as long as it is from a flat and small space. The engine powers the main rotor, and the blades on the helicopter spins fast, creating lift for the helicopter to lift off. Remember, lift makes things move up or rise. The fast-spinning blades lift the helicopter up against gravity. Gravity pulls things down. With the help of thrust, which is a force that pushes something forward, and lift, which makes something move up or rise of a helicopter, why do you think helicopters lift off and land vertically instead of taking off like an airplane? I like the way you think. Have you ever noticed the difference in design between a helicopter and an airplane? Well, the shape of the aircraft may play a part as to how each aircraft flies. Did you know that unlike airplanes, helicopters can not only fly vertically, but sideways, backwards, and they can hover. Hovering allows helicopters to remain in one place while in the air. Amazing, right? But how is this so? Take a look at this picture of a helicopter. Can you name some of its parts? Take some time to explore with your class now. Fuselage. This is the body of the helicopter. This can hold the crew, passengers, and cargo. The main rotor. These are the blades on the top that help the helicopter to fly. They act as a big fan. The blades are angled up a bit, so as they spin, the air goes down to allow the helicopter to go up. Landing skids. These keep the fuselage, the body, off the ground. Tail boom. This connects the tail rotor and the fuselage. Tail rotor. That is the small propeller fitted to the rear of the helicopter to go against the torque reaction of the main rotor and prevent the body of the helicopter from rotating in an opposite direction. A torque is the force that causes opposite rotation. And the cockpit. This is the place where the pilot controls the helicopter. It is Now That You Know challenge time. So now that we know the parts of a helicopter, let's collect all that we have learned and create our own helicopter model. Remember, as an engineer, you are solving a problem or need. There are many ways to solve a problem. I will show you one way to create your own helicopter, but please feel free to create your own. For this project, you will need an egg carton, scissors, tape, markers, design process notebook, and pencil and paper. So step 1, take time to ask yourself, how do you think each supply can help you make a helicopter model? Think about what each supply could be used for each part of the helicopter. For example, what part would be the fuselage and what part would be the main rotor. Step 2, brainstorm. What would you like your helicopter model to look like by drawing it in your design process notebook? Use the information we learned about helicopters, how they fly, and the parts of a helicopter to collect and use for your project design. D, develop. Start creating your project. So you are going to take a piece of paper and cut it lengthwise, vertically, down your paper about 1 inch thick. Again, you can decide what is best for your project. Now, with your strip, you are going to make a cut down the middle to about halfway so that your strip looks like the letter Y. There we go. And now you can trim the tail part. Here we go. And you're gonna fold the arms of the letter Y, as this will act as your propellers or the main rotor. Now we are gonna take our egg carton. You will have a tab right here, so go ahead and cut that off. Next, we're gonna separate this. Now you can tear like this, but if you need a little bit of help, you can use your scissors. You want to separate these. Now you will imagine what part of the helicopter this will be used for. I think you guessed it. This will be used as the fuselage. One cup will be the top, and the other cup will be the bottom. Trim what you need so that these can fit on top of each other. Now you can take time to use your markers and decorate the helicopter. Once you finish decorating, carefully with the help of your teacher, make a slit at the top of your top egg carton. You'll go in from the bottom and make a slit. Now you are going to add the tail of your Y-stripped paper and place it through the top of your egg carton cup. Trim what you need, tape what you need. Now you are going to tape around to secure your helicopter. You can use double-sided tape, you can use your glue from another unit, or you can use masking tape from a previous unit. I'm gonna tape All right, now you are going to evaluate and test your paper helicopter by standing on a step stool and dropping it to see if it will fly. This is where you can decide what works, what doesn't work, and do you need to bend the paper propellers or the main rotor differently. Think about if this paper is too heavy for your egg carton. Should you only use one egg carton and not the bottom? It is all up to you. Continue to evaluate. Finally, fine-tune and keep trying until your design is where you want it to be. That is all for today, STEAM Scholars. Today, we reviewed aerodynamics and specifically explored the aircraft of helicopters. Throughout this week, take some time to think about the similarities and differences between helicopters and airplanes. Before we go, take a look at these awesome Did You Know facts about aircraft. Did you know that the Tuskegee Airmen were the first Black American pilots in World War II? They were also known as the Red Tails, as the tail of their planes were painted bright red. They were not only pilots, but they protected the big bomber planes as they flew into enemy territory. Did you know brothers Orville and Wilbur Wright are credited in inventing, building, creating, and flying the world's first successful motor-operated airplane, named the Wright Flyer? And helicopters. Did you know that helicopters can be used for search and rescue, emergencies, fires, aerial photography, military activity, and more? I hope you enjoyed engineering your own helicopter. Next week, I will see you on Zoom or Google Meet as we will engineer a plane that can carry cargo. Remember, never stop asking questions. Don't forget to look over your STEAM career cards. And as for now, your teacher will read one of our books for this unit. Until next time, my STEAM Scholars, be great and keep exploring. Bye-bye.